Let us discuss alkenes. So in this lesson of ours, what should you expect? Number one, a brief introduction to alkenes. Moving on to nomenclature of alkenes. How are alkenes named? And of course, we cannot forget the isomers. Next, laboratory preparation of alkenes. Can alkenes be prepared in the lab? And if so, how? Last, discussion of the physical and chemical properties of alkenes. And I'm telling you, we are going to focus a lot on the chemical properties of alkenes because they are quite many. So let us dive into our lesson. So when talking about alkenes, these are a class of hydrocarbons that contain at least one double bond between two carbon atoms in a molecule. So when you talk about a double covalent bond, this is a type of bond whereby you're going to have two carbon atoms sharing four electrons between them. So one carbon atom shares two electrons, another carbon atom shares another two electrons, and in between the two, you have four electrons being shared. Now, I want to say this. This discussion of ours is actually the second part on organic chemistry. The first video was on alkenes. Now, if you need a good foundation on organic chemistry, I highly recommend you watch it. Now, coming back to alkenes. As stated, alkenes have at least one double bond, okay? So you're going to have a double bond being present between two carbon atoms. Now you can have one double bond, you can have more than that. But as long as you have a double covalent bond between two carbon atoms, that makes it an alkane. Alkenes are said to be unsaturated, okay? They don't have the maximum number of hydrogen atoms that they could possibly have. Okay, let me break this down by using an example. I want to use the example of ethane and ethene. Now, if you look at ethane, ethane has the molecular formula of C2H6. So you have 6 hydrogen atoms. So each carbon atom has the maximum number of hydrogen atoms. You know, it has 3 hydrogen atoms and therefore it's said to be saturated. Now, when it comes to alkenes, how about alkenes? If you look at ethene, same number of carbon atoms, but it has fewer hydrogen atoms, only 4. So each carbon atom has only 2 carbon atoms. So it doesn't have, the maximum number it should have. And the reason is because of the presence of the double bond. Remember, a carbon atom can only have a maximum of 4 bonds. So in this case, alkenes are said to be unsaturated. Now, when it comes to alkenes, they have a general formula, okay, similar to alkenes. The general formula though for alkenes is CnH2n, where N of course refers to the number of carbon atoms present. Now, let me give an example. Let's say I have an alkene that has 6 carbon atoms. Using this information and using the general formula, I can get the molecular formula. So what am I going to do is, in this case, if it has 6 carbon atoms, that means N is equal to 6. So C6. How about the number of hydrogen atoms? I will simply multiply 6 by 2, giving me 12. So in this case, the molecular formula is C6H12. As easy as that. Now for alkenes, the first member is ethene and not methane. Now when we talked about alkenes, the first member of that homologous series was methane because it had one carbon atom. In the case of alkenes, the first member is not methane but ethene. Now this actually makes sense because if we're talking about alkenes having a double bond between two carbon atoms, is there a possibility truly of having methane? Because meth means one carbon atom. So who will the carbon atom bond to? No one. It's by itself. So the first member of alkene is ethene. So ethene has two carbon atoms and therefore we can have the double bond between the two carbon atoms. Now, This double covalent bond that is present between the two carbon atoms is very important because it determines the chemical properties of alkenes. It is actually the one that makes alkenes to be very reactive. So alkenes are more reactive than alkanes. And the reason is because of the double bond. Now, because of this double bond is referred to as the functional group of alkenes. Okay, we are done with our introduction. Let us move on to the next, nomenclature. Now, when it comes to nomenclature, we are talking about naming of alkenes. So the naming of alkenes follows, a similar manner to that of alkanes, except in this case, we are going to replace the suffix "n" with "in". Now, stop there. Just like with alkanes, we are going to have a prefix and a suffix. The prefix is going to be based on the number of carbon atoms that are going to be present. Now, remember we said atuna meth? So, F means that this is an alkene with 2 carbon atoms, prop with 3 carbon atoms, but with 4 carbon atoms, and such. Now, the suffix, the latter part, is going to be in for all of them. So combine these two, ethene. This is an alkene that has 2 carbon atoms. Propene, an alkene that has 3 carbon atoms as such. Now, can we get the molecular formula? Of course we can. So as stated before, when it comes to molecular formula, this shows you the elements that are present and the number of atoms of those elements. So for example, the molecular formula of ethene is C2H4. What does this tell us? That we have 2 elements present, carbon and hydrogen. And we also have this specific number of atoms, 2 carbon atoms and 4 hydrogen atoms. Now, if you have the name of an alkene and you know the general formula, you can easily get the molecular formula, okay? So what about if I wanted the structural formula? Okay, so using the molecular formula as a guide, I can draw the structures of ethene, propene, and butane. So let's start with ethene, C2H4. So you know that you have 2 carbon atoms, and these are going to have a double bond in between them. Now you know that a carbon atom can only take a maximum of 4 bonds. So if you look at the carbon atoms, how many bonds does each remain with? 2. You're going to fill these with hydrogen atoms and boom, you have the structure of ethene, C2H4. So as stated before, carbon can take a maximum of 4 bonds. That is 1, that is 2, and there we have 3 and 4. So yes. How about propene? Now propene has 3 carbon atoms. So you're going to draw your carbon atoms. Then where are you going to place your double bond? It can be there or it can be there. Any is correct. So if you place your double bond there, the others are going to be single covalent bonds. Remember, when it comes to alkenes, as long as you have one double bond, that is considered to be an alkene. It doesn't all have to be double bonds. The others can be single bonds. So once you are done, the remaining is just looking for the number of bonds present in every carbon atom. So when naming alkenes, you have to take into account where the double bond is found. Is it found on the first carbon atom, the second, the third, and such? Now, the first 2 members, ethene and propene, are going to be written just the way they are. No number in between. Because they have, 2 and 3 carbon atoms respectively. So the double bond really has no alternative. It's always going to be on the first carbon atom. But for the remaining ones, starting from butene, you have to specify. Because if you look at butene, the double bond can either be there. If it's there, that means it's shared between the first and the second carbon atom, or it could be there between the second and the third carbon atom. So you have to specify. So in this case, because my double bond is located on the first carbon atom, that means the name of this is going to be but 1N. So now this is where we are heading to. We are going to discuss how to name alkenes correctly, taking into account the position of the double bond and any substituent group present. So as usual, we are going to follow the rules. Now rule number 1, determine the longest continuous carbon chain which will give you the parent name. Rule number 2, number the parent chain starting with the end near the double bond. Rule number 3, identify the name and position of the substituent groups present. Now I'm going to go through the rules with you by using examples. So our first example is that. So we want to try naming this. So according to the first rule, we are supposed to locate the longest continuous carbon chain. And it's that. How many carbon atoms do we have there? We have 5. So what is the name of an alkene that has, 5 carbon atoms? Pent. So that is our parent name. Now let's look at the double bond. Where is the double bond? Is it closer to that side or is it closer to the other side? That side, of course, right? So let's number the carbon atoms. 1, 2, 3, 4, 5. So where do we have our double bond? It's located between the first and the second carbon atom. So we're going to go with the first, okay? So our name is going to be pent 1-in. Okay? So pent, we have 5 carbon atoms in our continuous carbon chain. In, because we have a double bond. And 1, because this particular double bond is located on the first carbon atom. Now, when writing the name, we are going to separate, the name from the number using hyphens as such. So we're separating the name from the number by the use of hyphens. Okay, let's make it more challenging for us. How about that? So we have structure. Rule number 1, identify the longest continuous carbon chain. That is it. How many carbon atoms do we have? 1, 2, 3, 4. We have 4 and the parent name is but. So but hyphen in. So let's locate the position of the double bond by naming the carbon atoms. Now if we look at the double bond, will it be better if we start numbering from that end or that end? So as you can see, whichever side we decide to take, we are going to end up having, the same number, okay? Yeah, so 1, 2, 1, 2. But I'm choosing to start with this end. Why? Because if I start with this end, at the end, when it comes to the substituent group, I'm going to get a lower value too. Because if I were to start from this end, you can clearly see that my substituent group is going to be located on the second carbon atom. But if I were to start from that end, the substituent group is going to be located on the third. And what do we say? Always go for the lower value. So that end. So but 2-in. Okay. The double bond is located on the second carbon atom. Now coming to the substituent group. Now guys, if this is your first video, you're not going to be aware of what a substituent group is. Now, this is something I have discussed in detail in the first video under alkenes. So I've talked about what substituent groups are, the types and how you are supposed to incorporate them during naming. So please check it out. Now, when you talk about the substituent groups, in this case, what do we have here? We have an alkyl, specifically methyl. CH3 is methyl. So the methyl group is located on the second carbon atom. So 2-methyl but 2-in. Now guys, allow me to remind you of the following. We use hyphens to connect numbers to names, as is the case. So as you can clearly see here, we are connecting the numbers to the names using a hyphen. But if you have numbers, then we connect those numbers, okay, we separate them using commas. I'm going to do an example and you are going to see how we use the commas. Now I want to say this, don't leave any spaces in between the name. Don't leave a space between methyl and but like that. It's going to cost you, okay? So no spaces and no capital letters. Now, let's do another example. That. So, what is going to be our longest continuous carbon chain? Is it going to be that? Or is it going to be that? It's actually going to be this, okay? Yes. So you cannot have an alkyl at the first carbon atom on either side. Now, for those who decided that this was actually the longest carbon chain, this is wrong because you probably thought that the CH3 over there is an alkyl group. It's not. You will never have an alkyl group at the first carbon atoms on either side. If you do, then you're supposed to consider it as part of the continuous chain, okay? Yeah. So in this case, what is our continuous chain? It's that. How many carbon atoms do we have? We have 6. So hex in. Where do we have our double bond? If we start counting on either side, it will give us a 3, okay? If we start there, 1, 2, 3. If we start from the other side, 1, 2, 3. So our double bond is located on the third carbon atom. So the name is hex 3 in. Let's do another example. A bit different, right? Yeah. So again, the rules are the same. What is the longest chain? It's that. How many carbon atoms do we have? 5. So pent in. Where do we have our double bond? Now, if we were to start from that side, 1, 2, 3, it's going to be on the third carbon atom. But if we were to start from this side, 1, 2, it's going to be on the second carbon atom. And my dear students, where do we choose? The one that will give us the lower value. So we are going to start counting from that side. 1, 2. So 1, 2, 3, 4, 5. Okay. So our double bond is present on the second carbon atom, pent 2 in. Now on to the third rule regarding the substituent groups. So if we look at this, we can clearly see that we have two different types of substituent groups. We have an alkyl, we have methyl there. It's located on the third carbon atom. We also have chlorine. It's located on the second carbon atom. Now, how are we going to arrange this? Alphabetically. If we have substituent groups that are different, they are different from one another. Maybe one is an alkyl and the other is a halogen. Then how are you going to organize them to arrange them in the name? You are going to do so alphabetically. The one that is first according to the alphabet is the one that will also come first in the name. So chlorine starts with C, methyl starts with M. C comes first. So we are going to start with chlorine. 2 chloro, 3 methyl pent 2 in. And that is our name. Now moving on to isomers. What are isomers? Isomers are compounds that have the same molecular formula but different structural formula. So in short, they have the same number of atoms of carbon and hydrogen atoms, same number. But the way these atoms are arranged within the molecule is different. Hence, they end up having a different structural formula. Now, when it comes to isomers of alkenes, they are of two different types. We have positional isomers and structural isomers. Now, let's start with the positional isomers. These are isomers that have different positions of the double bond. The double bond is located on different carbon atoms. Maybe in one it's located in the second and the other is located on the third. Let's do examples, okay? So over here, we have this structure. This is the structure of but1in. Okay. Now, if you look at it, where is the double bond? It's on the first carbon atom. Okay. Now, let's look at this other structure, but2in. Where do we have the double bond? It's on the second carbon atom. So, see, first carbon atom, second carbon atom. Now, let's look at the molecular formula. I want you to count the total number of carbon and hydrogen atoms present in the two. So you're going to note that in both you have a similar, actually an identical number of carbon and hydrogen atoms. and that is C4H8. So they have the same molecular formula, but are their structures the same? No, they are different, and they are different because of the positioning of the double bond. In the first, it was placed on the first carbon atom. In the second, it was placed on the second carbon atom. And this changed the structure of the molecule. So these are positional isomers. Now we also have structural isomers. Structural isomers are formed when a substituent group is attached to a carbon atom in the longest chain. Okay, let me explain by using examples. So I'm going to start with pent 1 in, right? That, okay? Now, what if I was to take this CH3, cut it off, place it on this carbon atom. Okay, there. I would end up having a totally different structure, right? Yes. So in this case, what will happen is that I'm going to end up having a substituent group, and this is methyl. So how am I going to name this? As such. So number one, longest continuous carbon chain is that. How many carbon atoms do I have? I have 4. So bute. Where do I have my double bond? In the first carbon atom. So bute 1 in. The substituent group is present on the second carbon atom. So 2-methyl. 2-methyl bute 1 in. Now in this case, these are going to have the same number of carbon and hydrogen atoms. Just count and you're going to find out such. So they're going to have 5 carbon atoms, 10 hydrogen atoms. But are their structures the same? No, they have different structures. And the reason why they have different structures is because there is a substituent group that is located on different carbon atoms. Hence, overall, we end up having different structures.